All right, we're going to go ahead and get started. I'm going to put my name or email address down here at the bottom in your GoToMeeting dashboard. If you'd like to send comments or ask questions after the fact, you can send me an email or request this recording. I did request the earlier one at 8 o'clock, and I'm going to record this one as well. My name is Darren Bryant. Email address is darren.bryant@solidcam.com. That's darrin.bryant@solidcam.com. If you have questions throughout the webinar, just go ahead and type them into your GoToMeeting dashboard, or just wait till the end. I'm going to go ahead and take questions and answers at the end if we have any. Today is SolidCAM Basics Part 2. 2 weeks ago we did SolidCAM Basics Part 1, programming. We got into some beginning of programming. Today we're going to try to get into some more. Doesn't seem like we can cover that much in an hour, but we'll try our best. So let's go ahead and jump in. Now last week, or 2 weeks ago, we started with a pocket, and we turned that pocket operation into a profile operation because there's extra meat here that we have to take off as compared to the sidewalls. Now with pocketing, you can chain the outside edge and call that an open boundary and chain the inside edge as your actual part, and then it knows exactly where the material is and you're not wasting time in air. However, profiling basically just does a profile and you go around it and you can decide how far you want to start out. So I'm going to go ahead and show you that. We did pocket last time, but we're going to go into profiling this time. I've already set up some coordinate systems in case we get to some other sides, but let's go ahead and choose the profile that we want to cut. I'm just going to go ahead and select this edge here, and it's important to note where that vector of the tool is right now. That's the direction the tool is going to go, and it's going to start here unless you don't have your settings set up to start at the very 0 point, because by default in the settings it starts about 25% from this corner. This is the direction the tool is going to go, and in profile mode it always defaults, the tool always defaults to the left side of the line, so you're doing a climb cut. Now you can switch it to on the right side, but then you'd be doing a conventional cut and you'd be on the inside, or you can put it to where you're cutting dead center if you'd like, and we'll get into that. So it's important to note where your start point is. Now I selected the line somewhere on this edge. As long as you're behind the 0 or the middle point, if you're over on this, closer to this side of the line, it's going to grab this point. If I had selected over here, it would have grabbed this point and went back the other way. Does not matter. You can always reverse the toolpath right here. And another way to reverse this toolpath, just let's say I did select it here, but I want it to go that way. I can just simply select the next line in the element, and it automatically reverses it. I'm just going to go ahead and chain that all the way around, and we'll call that outside. Tool, let's go ahead and just create a quick 1/2 inch tool. And make that 1/2 inch. We'll just do, I don't know, 1.75, 1.5, 1.5, and 4 flutes. That's fine. Not worried about a holder or anything. All right, levels. We'll start cutting at the top of this block, and we'll cut down to the bottom of the part here, which I have extra material and stock down here, so I'm gripping on it with the vise right here. But I do want to go down a little bit deeper, so we'll go 20 thousandths. All right, inside technology, we have our left side, we have our right side, and our center. You can also do stuff in here, and I'm going to talk about this in a little bit, but by default it goes to the left side of the line. If we just produce this the way it is and go ahead and turn it on, you can see we have a basic profile. It goes around that profile that we chose. No step downs, no step ins, nothing. Also, notice that it didn't start right at that corner. It started right here. Let me just show you where that's at so you know. Inside your SolidCAM settings, and it might be over in these settings as well. That was under Geometry. Here it is. So start position shift. Default, it's 25% of the first edge. So 25% over of that first edge is where it started. Not 25% of the whole profile, but 25% of the first edge. Or you can make it start right at 0. Now, you can leave this here. There's a reason for that, because if you're in the corner and it wants to put in a lead and a lead out, It's trying to avoid the gouge altogether. However, without messing with the settings, you can adjust that start point over to the corner. And that's something you do inside the Geometries button right here. So if you go into Geometries, you're going to see there's quite a few things in here we can do. If we look at the very top of it, you can see your tool, where it's at, and then you can move it. You can give it start extensions, you can virtually modify the offset, or you can shift it. And we'll come back to these. But shifting, all you do is select it, put your cursor in here so it's blinking, and you could literally click anywhere you want to start that tool. That means if you want to start at that corner, go ahead. Okay, or you could just type in a 0. Now you can also project points. So let's say I want to start at the center of that wall right there, or the center of this one. What I can do is I can project these points right here that automatically projects normal to the profile. That works for anything, any point you want to do. Like if I select here, it's going to project normal to the profile. Kind of a handy little feature. So we'll go ahead and come back to here, and let's take a look at the modify offset. This is like cutter comp, G41, G42, but it's a virtual cutter comp, and it does work in conjunction with cutter comp, so you can use it together if you'd like, but you can put in, negative or a positive value here, and you can modify that profile that you created without modifying the actual part. So nice little handy feature again also, but it's really more used not so much for cutter comp, because you got cutter comp already, but if you're like just way off on one side somehow and you just didn't feel like changing the size of this or something, you could make it bigger or smaller very easily. Start extensions and end extensions, these are great. Let me just show you here that you're actually going around the corner. It's rounded, right? Well, it's not going to actually create a rounded thing, but it does kind of come around there. If you're really wanting it to be virtually sharp, there's a few things you can do. Here, let me go ahead and update the toolpath first to update our start point. Now what I would probably want to do is I'm going to back off, because it does not like to cross over itself. The profile that we cut, we don't like to cross over right here. They can touch, they just can't cross over each other. So if I decided to take that start point and maybe bring it back, so you can put in a negative value here. Let me just show you 1/2 inch. See, it brings it way back here to this point right there. So you can put in a negative or a positive value. Actually, a positive won't work because it would be crossing over that line. So I'm going to actually say negative by 1/1000. So if we zoomed way up, oops, what happened? Negative 0.001. It's because I clicked over here, which you can also do, obviously. So if we zoomed way up, you can see that the start points, I'm actually 1/1000 away from the corner. Now they're not crossing over each other. Now what I can do, let's go ahead and accept that, and I'm going to go ahead and hit save and calculate. Now we have a little bit of a gap here, but if we want to just lead in straight here and lead out straight there, you would have set that up the way I just did it. I'm going to go into links, and we're going to simply do a tangent lead in, and we'll say, I don't know, 375 lead in. You can also put in an angle. So that's for the lead in, so that we just added a lead in there, and then we could do the lead out the same as the lead in. Lead in and lead outs don't mind crossing each other, but the actual geometry does. So if you're looking to get a straight lead in and a straight lead out, there you go. Now, if you're looking to get all these corners virtually sharp, I don't know that they have a virtual sharp in here, but you could do them in individual stages. Excuse me. All right. So that's basically what's inside your geometry button. It's very useful. Let's go ahead and just turn this off for now. We'll accept that, and we'll turn our tangent lead in, lead outs to, actually, let's do this, save and calculate. Oh, look at that. We didn't need that at all. So let's start this at the shift button, 0. We'll accept that and save and calculate. Oh yeah, we did. There it is. Now you notice that we came around that corner, so we would need to put in that if you're going to do a straight lead in, lead out. I'm not going to worry about that. I'm actually going to turn on an arc. So let's do a 250 radius, 90 degrees arc. So as you click in here, you can see you can add a little line in here. You can define your arc size. You can define how much of that. You can do 45 degrees if you wanted. That'd be fine, or 10 degrees, doesn't matter. And you can turn on a little straight line move. Most machines require a straight line move to turn cutter comp on, that G41, G42. And I'm going to make the lead out the same as the lead in. So save and calculate. Now we got a little straight line move to turn cutter comp on, arc into the wall, go around, arc off in the same location. That could potentially leave a witness line. So if you wanted to, you could throw in a little overlap right here. Extension overlap, we'll put 100 there. Now we're entering here, we're going around the part, and we're going past the entry point and off at a different location. Give you a better chance of not leaving the witness line. Now that's just a simple profile, and we're rapiding down, as you can see, outside the material. That's why I did the ramp in. I didn't want to come right down on the material. Although that might be touching the material, it's probably really close. It's a 1/2-inch tool. That's 250 of material right there. So for the 1/2-inch tool, it could cut this no problem, but we would leave material right here if we cut this. So if we took it into simulation, solid verify, let me check a couple of settings real quick. Defaults and setting accuracy, we'll do 5 thousandths, or 5/10, sorry. So leave that, come back in, because that resets it, and play it. So notice we have some material out here. So that's a basic profile. Now you can take extra material either starting at the Z and work your way down, or from the outside and work your way in. You always have to have one technology on. If I turn this off and try to calculate it, it's going to tell me there's no operation defined, because you either need roughing or you need finishing on. Okay, right now we just have finishing, one pass with an overlap, but no step downs. If you want to add some step downs in there, let's do 300 thousandths. Save and calculate. Now you've got your step downs for the sides if you'd like to rough that out doing that way. Notice that they're unequal steps, though. It's 300, 300, 300, and then whatever's left over. I think I went down 1 inch 20 thousandths, so that'd be 900, and we'd have 1 inch or 120 thousandths as the last step. I want them equal. If you want those as an equal step down, just simply select equal step down, save and calculate. And now you have some equal step downs. So how does that work? Just so you know, remember I went down, I only went, let's see, where's my levels here? Yeah, I went down 1 inch plus 20 thousandths. So if I'm doing 300 thousandths, we have a 1 inch 20 thousandths, and we divide that by 0.3, which is our step down, we get 3.4. Well, we're not going to do a 3.4 step down. That doesn't make sense. So what we do is we take that 3.4 and we round it up to 4. So now we take that 4 number and we divide that by the 1.02. So 1 inch 20 thousandths divided by 4, which is the whole number, and that's the actual step down that we take, 255 thousandths. So anytime you see max step down, see, notice when I turn this on and off, that's called step down, so it's going to take an actual 3. But as soon as I select it, it says max step down for both roughing and finishing here. So we'll go ahead and leave that there. Roughing. Now this would be roughing for your step down, or your step down as well. But this is for finishing. So if we turned off this, we could do, say, stay away 10, and our next step down would be also 3. Save and calculate. You're going to get virtually the same thing, except that now I've opened up that wall offset because I'm doing a finish. I'm not doing a finish, sorry. If I turn that on and turn this off, you can see that this gets grayed out. So if you're looking to do a rough step down and you want to leave stock, that's the way you're going to want to do it. We don't need to leave stock on the floor because we're out in the middle of nowhere. Now, let's say we wanted to now rough out the rest of this here. We're fine on the walls here, but I'd really prefer to have a step over here. Well, that's going to be in your clear offset right down here. So you can either type in a value, say 250, and I generally do both the numbers the same. That should come up with 2 steps. Yeah, 2 steps. But still, we might not quite get that corner out. So you might want to do 3 steps. Let's do 0.375, and we'll do 0.1875. Now we got 3 out there. That would probably do it. Here's the problem. Look how we're wasting a bunch of time out here. Okay, that'll definitely rough it out. Yeah, see, we did leave a little chunk out there. So that's not even enough. So let's go 0.4, and we'll do 0.2. There we are. There we are. So that is one way to do it, but that's a waste of time. And that's why we showed you 2 weeks ago how you could use a pocket so you're not wasting that time out there. However, now you know how to use offset. By the way, if you didn't know what that value was, you could simply pick the offset button and select that corner. It's automatically going to measure from there to the profile and give you some values. Then you'll know, let's say an 8 is right there, but I wouldn't want to come out that far because it's going to start way out here. So I would probably cut that in half, which is like 440, which is about where I was at, and we'll do 220. All right. So that's what clear offset for you does. It just adds material so it starts out a little bit further. And we'll go ahead and leave that on where we're at because I need to remove the material on the outside because we're going to do a chamfer operation as well. But before we do that, let's see if we can discuss any other things in here. This I'm going to have to discuss by doing the corner or the side here. Rest material, we'll talk about that in a second. Yeah. All right. Let's move on to another operation. Let's go ahead and do our chamfering operation right here. Now that we've roughed the outside, we're going to go ahead and do this chamfer operation. You can do that in pocket mode, or you can do it in contour or profile mode. We're going to do another profile. So grab our profile, which actually is the same profile that we're going to be using from the outside of the first one. I think it's easier if you select the bottom edge of the chamfer, and since that's the one I selected before, I'm just going to use the same profile. Tool, now you're going to want to select your chamfer mill right here and give it a size. Will be 375, chamfer mill. Just make sure that you got enough flat on here to do your chamfer, and if not, if you have a smaller one, a smaller chamfer mill, and you need to go down a bigger angle, well, you can set that up with your drafts, and I'll show you that here in a second. I'm going to go ahead and select this tool. Also, FYI, make sure that your angle is the proper angle here. So if this is 45, then you want 90 here. If this is different, then you're going to get what the tool gives you. So levels, yeah, it's not real important, honestly, here. So I'm just going to start there, and we'll, feed down to this point right here. So 62 thousandths basically is what my chamfer is. If you want that to be associative, make sure to pick an endpoint, not just the edge. Okay. Now, in technology, you have a rest material and a chamfer operation. We're going to go ahead and choose chamfer. As soon as I do, it's going to create a tab and throw me into it. So if you want to get back there, you can go here. But here's the chamfer tab. Now with chamfering, there's really nothing here you have to mess with. It's really this value right here is all that matters. And that is pretty self-explanatory. It's driving, this is 50 thousandths right here. So if you put in 10 thousandths, it would drive the tool down here somewhere, or 1 thousandths. I don't think you can have a 0 value. Let's see. Yeah, 0 won't work, but you can put it in, like, say, a 1 thousandths. So it would be way down here at the tip. But for now, I'm going to put in 10 thousandths, and I'll show you how to move that up and down. So we're going to go ahead and simulate, and I'm going to step through this. Let's go here, and we're going to step. Oh, did I do a lead in? I don't think I did. Let's turn that on. No lead in. Let's do a lead in real fast. Arc, we'll do 250, 90, and maybe a straight line move. Okay. Save and calculate. There we go. Now, as we go down, you'll see that's an arc in right here. Notice you are right at that tip. We did 1,000, so it's hard to see, but there's the tip down there. You're right at the tip of it. Okay, that is a way to avoid, if there was a shelf down here, how would you avoid the tool not touching the shelf? Well, you give it a smaller diameter size and it pulls this tool up further. Yeah, maybe I did too much. Did I do a negative or something? Oh, you know why that is because on my roughing pass, I left material. So let's go take that off so it makes a little more sense. So technology, I left 10 thousandths and I never did a finish. So we'll do one finish pass at the full depth. Save and calculate. Now if we take this into simulation, it'll make a little more sense here. There we go. So now you can see that you're just right on the tip. One chamfer move, and of course you could take that down in Z if you wanted, a couple thousandths at a time or 10, 15 thousandths at a time, up to you. Now if we wanted to move that tool down to where it's cutting more at the top of it, you just put in a bigger value. Chamfer, let's put in 150. Save and calculate. We'll take that into simulation and solid verify. Let's step that through. And now you notice that you've actually driven the tool down further. So you can control where that tool is. Now, just a quick FYI, if you are needing to, you have a smaller tool but a much bigger chamfer and you want to take it in multiple passes, then you're going to need to turn on your angle, which is right inside your advanced. And you can say wall draft, and you could say, let's do 45 degrees. Save and calculate, and then you're going to need to put in some passes here. Let's do 10. Let's see what happens. There we are. And now you can see you can actually drive down that angle. And we want equal steps too. Why not? So that is that's how it works. Let's verify that I did that right. I didn't. I was way too far away from it. Let me try something here. Offset, modify by 150. There we are. So what I did is I modified the offset because when you do the angle, it throws in that diameter that we put in for the 150, that where I put in the chamfer diameter, and it uses that. So if you're going to use a smaller tool, whatever value you put in here, right here, you're going to want to put in a negative value in here to make that work. All right, so that's chamfering. Rest, I probably should show rest, but that's better shown with pocketing and probably with the smaller tool. But yeah, let's go ahead and show it, because I do want to show you rest. So let's go ahead and pocket out this one right here. And I'm going to do this in pocketing, but it works in contouring as well. Let's go milling, pocket, and we're going to say that it's the inside now. So I'm going to grab this edge, chain that around, we'll call that pocket. And we'll use a much bigger tool. We'll use a 1-inch tool, because these corners here are actually, it's a 5/8 tool that creates that, so we want to use a nice big tool here. And mill. All right. Let's do 125, 125, 125. That's fine. So I'm just trying to get the material out of here to start with, and then we'll do a rest operation. And by the way, rest operation stands for RE is the first two letters in remaining, and ST is in the first two letters in stock. So rest, remaining stock, rest. That's why we call it that. Let's do a step over of 75, or an overlap of 75, and we'll turn that on. All right. So there's our pocket operation, and that may be a little bit hard to see, so let me change that to like yellow or something. Save and calculate. There we are. All right. So it's coming right to a sharp corner. You don't see it rounded, so obviously it's not cutting in there. Now, if it were exactly the same size, it'd still be sharp, but I know that the tool is too big. So if we took this into verification, actually, let's make sure that we don't have anything left. That's fine. Here's, by the way, is your rest and chamfer again. Let's take this into simulation and play it. And if we were to use our rest option, this is a show hide rest material. You can change that color, by the way. I'm showing in green. By default, you'd be showing it in red, but you can go into visual properties, and I said rest material. You can also make it transparent, but I turned mine to green because it was at red. I just didn't like the color. So you can change that if you like, but you can clearly see we have material left over in this corner. We have material left over in this corner. So we want to take that out. So what I'm going to do, and I don't want to take it all in one chunk because it's kind of deep, so I can either step down or I can work my way into there. So what I'm going to do is I'm going to do we can even do a save and copy here, or you know what, let's try a profile now. Now let's do this. We'll do a save and copy, and we're going to change the tool size because we want the tool size to get in there first. So I'm going to use a 1/2 inch tool. That will easily fit in there because that was a 312. So a 1/4 inch radius of the tool will fit, no problem. Levels are all fine. Technology is fine, except that we want to change this to a rest operation. Now, you can do the whole line, the whole profile, going all the way around, or you can just do it in the areas where it needs it. It's kind of like, there's another word for it, but I can't think of it right now. But this will only do the corners. Now, you can type in the previous tool size here, or you can pick it from your list. And it's just going to put in a 1 for me anyway. Previous wall offset, I didn't have any on there, but this would be as if you wanted to leave material in there. I don't know why they call it previous, but if I left 10 in here, it would leave 10 thousandths in there. I don't want to do that. I'm going to take it all out. Overlap, because we're using a 1-inch tool, so that 1-inch tool probably touched right about there somewhere. Let's go in here. It probably touched right around here and right around there because it's a bigger tool. So if you wanted, you could put in an overlap. We'll do, say, 150 thousandths just to be safe. And that just gives you a little extra room out here, so it makes sure that it takes that out. And let's go ahead and save and calculate, and we'll turn that on. And now, it's, by the way, it's doing this, and it's got that extra overlap right here. If you want to, kill some of that overlap, let's do, where's my overlap? Where was I at? It's right in here. Let's just do 50. Notice how it gets smaller. We'll go with that. And we have 2 cuts right here, but actually I don't want it to do, I want it to do more cuts in there. So we can just change this value. This is an overlap, so it's only 5% of the cutter is cutting. Now I get extra cuts in here. So, in all the corners. So that's remaining stock, rest material operation. Let's go ahead and hit play on that. You can see it cutting. There we are. And if you want, you could run your rest material operation. You can see that we've taken it out. Don't worry about this. This is just your faceting tolerance. And actually, those should be, I wonder if that's just a facet tolerance too. We should check that size right there, just real quick on the model. Make sure that it's also big. Yeah, it's still big. So that's just a faceting. All right. I wasn't going to show fillet rounding, but there is one other thing in profile, because fillet rounding I really want to talk about, or corner rounding, I really like to talk about creating custom tools. I don't think we'll get to that, but I do want to show you another very important feature inside profiling. All right, this time we're going to go ahead and do some work up here. I think it's up there. Let's check that. Yep. Okay, so we want to cut out this profile right here. But I don't want to drill a hole. I don't want to ramp back and forth. I don't want to peck drill in there. I don't want to helix in. We have a fifth option, and I'm going to show that. For any open or closed profile, we have a fifth option for getting into the material. So let's go ahead and pick our geometry. Now, 2 weeks ago, we went through the selection method here, and we didn't really touch on multi-chain. Multi-chain is kind of nice. You can different ways of selecting your geometry. You can unselect, so it's just kind of like a toggle. You can pick edges, you can pick text, you can pick faces. You can turn on some selection filters like from and to entities. You can do loop filters, which you can choose this face and choose all inside profiles or all outside profiles if you wanted to. You could say this, we'll say faces, and we want internal loops only. I can select that, and it selects the inside loop only. Or we could do, let's cancel that real quick because I don't want to select it. We'll go back in here. You could go into CAD Select. And what it's going to do is you're going to want to come up to your CAD, and you're going to want to select the sketch that created that feature. So it's going to grab everything, including the center lines on here. So I'm going to resume and select OK. It's going to list all of them. It shows you what they are, numbers them. It also tells you which ones are open or closed. So we don't want the two open ones, so I'm just going to simply delete those. And now we have just the one profile I want. And we'll call this slot for now. All right. Tool, we'll use a 1/2-inch tool. That's fine. Levels, again, we're going to pick from top here. And we're going to go on down, well, at least to that point, but I'm going to add a little bit more because I want to go past it. So I'm going to put in a 30 thousandths, give me a total of 1/2 inch. Okay, we talked about this stuff in here, but this is very cool. I'm going to go ahead and generate the tool path, and I'm going to turn it on for you so you can see it. So we are down below 30 thousandths where we want to be. Let's go ahead and put in some step downs so you can see how this next feature works. Let's do 100 thousandths. So there's 100,000 step down. Right now, currently, it's actually just plunging straight down on the wall. So first of all, let's go ahead and change our start position just to get it off that corner. I don't like it in the corner, so we're going to shift it, put our cursor in here, and simply, I don't know, pick to the middle here. That'd be fine. It's probably 35, so we'll go right there. Going to accept that and save and calculate, move my start point, and then I'm going to go ahead and turn on a lead in and a lead out. And we'll do, say, 190 degrees and a little 15 thousandths again. Lead out, same as the lead down. Let's go ahead and get that. All right. So in this case, obviously we can turn on all kinds of ways to get into the material. We also have this depth type here, and this is what I want to talk about. You have constant, which is basically just going straight down. You have define, which we're not going to go over, but we're going to talk about helical. Helical sounds like it's going to go down in a helix, in a round circle. In pocketing, that's what it would do. But for an open or a closed profile, it's called helical, but I would call it profile ramping. Because that's, if you look at the picture, that's actually what it's going to do. While it goes down, or while it goes around the profile, it actually drops that 100,000. So for every time it goes around, it's 100,000 slower when it gets back to this point. And it continues to do that until it gets to the bottom, and it makes one complete pass at the same level and arcs off. That's an extremely powerful feature because when you apply down pressure to an end mill like that, it tends to stay right on line. It doesn't pull to the conventional side, and it doesn't pull to the climb side. The other benefits are far-reaching as well because you can wrap this around a 4th axis as well, or you can use it in 5-axis. So it's an extremely powerful feature. Probably the second most used toolpath that I use all the time. Very cool. All right, let's see, what else can we do to this? Yeah, we could talk a little bit about that. Let's stick to, let's see what else we have here in the list. Yeah, I think I will go over. I'm not going to show you how to create an actual tool for custom tools, but I will show you how to select that for your tool. I probably should do that in a different setting. Let's see. Yeah, let's go ahead and do it. Let's check here. What else can we go over instead? Well, 3D contour is pretty handy. That's really the best way to explain 3D contour is think about a wet noodle, like you just got done cooking a noodle. And you have this, it doesn't matter what kind of shape of the part. It could be an organic shape, doesn't matter. Take that noodle and drop it right on your part at any angle. Doesn't matter if it goes up and down in Z. I know it's technically from here to here is 2-axis stuff, but they do give you a contour 3D. This is made to do one cut at wherever this thing goes. It doesn't have to be in a straight line. It can be curved. It can go up and down, but it basically follows that edge. We don't really have. Well, we could, I guess, follow this down around here. Let's do that. Let's try it. 3D contour. Let's see. Now let's do it on the back side. There we go. And we'll just for a lack of better places to go here, we're just going to come down this. So I know this is straight, but this literally could go in a loop or an S-curve all around your part. Doesn't matter. If you're just looking to trace one line, it could be used for trimming. You could use it for etching if you wanted to. If you wanted to etch out a certain weird shape, that'd be fine. Go ahead and accept that, and we'll call that 3D contour, just so we know what it is. Tool, we'll just grab a simple, small little, I don't know, 1/8" cutter. And it's a ball, that's fine. Levels, I'm not going to worry about the levels right now. We might come back to the contour depth. Let's start with center. Notice it always defaults to center. And we're going to go ahead and take a look at that. Let's hide this real quick. So notice it went straight on center. It just basically followed that line right on down. So if we were going to, I don't know what it's going to look like in Verify. I'm sure it'll be gouging something, but just going to go down. There we are. So actually, pretty cool little feature. You can obviously change the depth on it. So if you want to contour depth, if you want to go a little bit deeper, you can go ahead and do that. Other things you could do, maybe you don't want to be on center, maybe you want to be to the left of the line, and you could turn color comp on as well. No operation defined. Oh, sorry. So it was on center and it had one of those. Oh, center, I don't need it, of course. Left, we'll say one finish cut. And of course, you can do roughs, side steps, rough down, clear offsets, all the same thing, pretty much all the same stuff that you have in profiling mode as well. So let's go ahead and do that. Now we're offset a little for that 3D profile. What else do we have in here? Advanced, final cuts, no. Parallel finish, let's do center. Semi-finish, so you can do a step down in your Z as well, even if you're on center. Notice that your rough and your finish is all grayed out. You can also change your reference point from tip to center. So center of the tool versus tip. That'd be the edge, or on a ball nose, it's the tangency point. On an end mill, it's the end point right there of the cutter. And that will give you strange toolpath, especially if you use it in end mill. Let's just go ahead and grab one. Oh, I did it again. There we go. Save and calculate. Actually, on this one, it's not so bad. Let's go back to our center and see what happens. Yeah, it's not so bad. But you will see that on different things, it'll look warped. Sometimes it'll cross over itself, depending on which tip reference or tool reference that you choose. So hopefully that's understandable. You can do some lead in and lead outs. Let's go ahead and close that. So that's 3D contour. Let's see what else we have that we can get into, because I really don't want to have to touch on custom tools yet. I can surely show you how to connect them to an actual tool, but I'd really like to do that in a separate class. Now, we did touch on milling or drilling, and I believe we actually touched on, let's double check that, make sure that we did get to it. Hopefully we did the chamfering 2 weeks ago. 2 and angle bracket. So we did do a chamfer on there, didn't we? That was drilling the hole and that was chamfering. So yeah, we touched on that. Okay, so we're not going to do chamfering. Actually, I think I'm going to go ahead and open this up for questions and see if you guys have any questions of what you've seen so far and any other ideas of where you might want to go in one of the profiles, if there's something inside the profile, because I really wanted to cover that. And Brad, yes, I will send you, do me a favor and shoot me an email. Send it to Darren.Bryant so don't forget, because I'm going to have to let this process for about 30 minutes, 45 minutes, and after the meeting is closed, and then I can send it out to you. Showed how to do the angle on the bracket. Okay, I'll go ahead and do that, even though technically I should leave that for HSS. I know that I said I was going to do that last week, and then I decided not to. For the angle bracket, what he's talking about is these angles right here. Now, of course, you could do what I showed you in chamfering. You could cut it back and forth this way, but let's be honest, cutting up this way would be better. And because our system comes with 2 3D toolpaths it doesn't matter what kind of 2D system you bought, whether it's 2D Express, Standard, or Pro, it does come with 2 free 3D toolpaths. And what are they? Well, it's the HSS. HSS stands for high-speed surfacing. It is our full 5-axis module, but what we did is we locked out the 4th and the 5th axis so you can use it in 2D or in 3D, doesn't matter. Now, in HSS, we've given you 2 of the most popular toolpaths, which is linear and constant Z. So let me shut this door. Linear and constant Z are the 2 most popular in the entire industry. We're going to go ahead and do, for these, they're straight, so we're just going to do linear. So linear is just taking a cut across something straight. So the toolpath is always moving in a straight line of some direction, and you can change that direction to whatever you want. Let's make sure we're in the right position here. So let's take this angle right here. I've got our coordinate system, geometry. Now this is the other thing. Since this is the full 5-axis module, you have to pick individual surfaces. In 3D milling and 3D HSM, it looks at the whole target. And then if you want to define where the tool goes or doesn't go, you use boundary curves. However, inside 5-axis, it's always picking the surfaces. Now, there are ways to create boundary curves for that, but mostly you're picking the surfaces that you want to cut, and then you're gouge checking against other surfaces. In this case, we don't have to do any gouge checking because there's really nothing around it. So pick the drive surfaces. The drive surfaces, picture it as the road. The tool is the car, the surface is the road. So I'm going to cut this surface right there. We'll come back to this maybe. Let's go grab a tool, and we'll grab, I don't know, do I have, I already have a ball in there somewhere. Oh, no, I don't. Okay, so let's create a new ball, and we will do 1/4 inch should be fine. For flute ball mill. Okay, that's fine. Leave it there. Levels, again, 5-axis software, guys. So you can exit or wrap it in X, Y, or Z. You can go around a plane or a cylinder. You got retract distances. All this stuff is really for 5-axis. So notice it defaults to Z and 1-inch plane height. That's all you really need to do, especially if you use it in 3D. But if you want to get all fancy for some reason, you've got the options too. So in Toolpath Parameter, so here we set what? We grabbed the faces, we grabbed a tool, we didn't even look at levels really, and Toolpath Parameters. Now, the way Toolpath Parameters works, like this cut tolerance, let me turn that on. It's not going to show you. I'm going to show you exactly how when surfaces are cut, and I'm talking about this particular cut tolerance right here. This is a surface quality. And just for the people that don't know how it works, okay, let's say that's the surface that you're cutting. All surfaces have to be cut point to point. So what does that look like? That's like going like this, okay? And these are attached. It just doesn't allow me to do that with that line. So the distance right here is the cut tolerance. So if you have 0.0005, then that's the distance here, and obviously the line gets shorter because they'd be little straight line moves in order to create, a circle. They'd be a bunch of series of little straight line moves. I'm terrible at drawing freehand, so you get the idea. So this line will shorten the smaller this number is because that's the closer you are to the surface. So that's how surface tolerancing works. So when it says, and you can use the slider here if you'd like, and by the way, in the settings, you can change what number starts and what number ends here. So you don't have to use these, or you can just override these altogether and say, I want 5 thousandths or half a thousandths. Okay, so we'll go half a thousandths. This is your step over. So here's a scallop in case you don't know what a scallop is. I'm going to show you that as well. Let's draw the tool. And let's say this is the step over of the tool. Okay. Here's our surface. The scallop height is this right here, that distance from here to there. So we're talking about this area in here, all this black. So that's a scallop height. And it is in direct relationship with the step over from the tip of the tool. Okay? So you got a distance here, you got a height here. So this is your step over value, this is your scallop height right in here. Just like that. All right, so 50,000 step over, that's only 125 wide. That's going to be really, really big. So let's start off with 10 thousandths. Notice how the scallop height's changed. It's only 1/10 scallop height. That's referring to right there. I have to show the picture down here. I like drawing it. So let's go ahead and generate the surface and see what we have so far. There's a nice little cut going up and down it. We are in zigzag mode, so it's just doing a nice crossover, and that's fine. If you don't want to do zigzag mode, that's going to be in your toolpath parameters under sorting. So we're in zigzag. If you want to do one way, you're going to get a lot of rapids. Okay. Let's do zigzag because zigzag's not a problem. But we're going to do one other thing. This is the center line of the tool where this ends. So that's going to be, should be tangent right to the top of that. But let's say we want to go a little bit further or a little bit further down here. Not a problem. go to your geometry, and you have an extend trim feature here where you can say, let's go ahead and do an extra 20% of the tool diameter. That's how much more I want to go up here, and 20% at the bottom as well. Select OK, save and calculate, and you'll see the toolpath change. Let's make it a little more drastic. Let's do 100%. Ready? Watch the toolpath. Okay, so great way of extending the tool. And really, you probably only need about 10%, honestly, but we'll leave it at 20. Save and calculate. Now, this is just one cut. Now, you might be thinking, well, I got kind of a lot of material. That might be a big cut at first. Well, you know, it might be. So if you want to do that, we can actually put in roughing. That's really getting into HSS, though, and I don't really want to cover that right now. But let's go ahead and take this into Solid Verify, and we will step through it. Oh, also it's starting at the top. I don't want to do that. Okay. So that's basically it. So if you don't want it to start at the top, again, you can control that as well. That's going to be in your Toolpath Parameters and Sorting, and you can simply say flip step over, and it'll start at the other side. Save and calculate. Oh, better. There we go. And now, starting down at the bottom. Yeah, because it touched my shank because it was kind of a long cut. Now, if you wanted to start out further, you're going to be turning on actual roughing, and you're going to be probably doing multi-pass right here, just an FYI. But I'm not going to get into that today because we're just about out of time. So I want to make sure that we talk about any kind of questions that might be coming up. This is a great way, by the way, HSS, the reason we've included that in with all the 2D packages is because it's a great way of doing fillets. Let's go back to the one part real quick, the sensor housing. It's a great way of doing this fillet cut here if you don't have a fillet cutter. You could use a ball nose tool. So in this particular case, we could do HSS again. I won't use linear this time. I would use constant Z. And then for a geometry, I'm going to go ahead and pick the surfaces that I want to cut. So I'm going to cut this, this. We'll cut all these fillets here. Oops. And this one and this one. Okay? So we got our fillet. We grab our tool. We'll go ahead and see ball. What is this one? No, it's an end mill. There's a ball. There's an 1/8" ball. Go ahead and select that. Not worried about that. Toolpath parameters, we're going to say 1/2 thousandths again. And step over. I'm going to do 1,000 step over because that's a pretty small fillet. So let's just go with that for now, and then we'll turn on what we need. So what it's going to do is it's going to come down. It's going to go around. It's going to rapid. Oh, it's a zigzag. So it's going to go all the way around, come down, go back up, step down, and go back around the other direction. If we want to go one direction always, again, you can do just one way. So change it to zigzag to one way. Now you're going to get links up here. There we are. So it goes around, picks up, goes over. Now, what if you don't want to do this? Well, that's where this HSS comes in very handy. That would technically be a gap along the cut because there's a gap right here along the cut that you want to make. So in your linking moves, you have gaps along the cut and you have links between slices. I'm getting way too detailed right now. But let's go ahead and just change the gaps along the cut. We don't want it to go to the clearance area. We'd either prefer to go direct or you could even follow the surface. Let's try direct. Maybe that's a link between slice. That might be considered a link between slice, so let's do direct. There it is. We'll go back to clearance area and see what that is. There we are. So now you have, it'll come around. It's just going to come straight down, and it's going to, actually it looks like it's starting at the bottom. Yeah. Well, let's see. I don't know where it's starting, so let's do a solid verify. Okay, it's climb cut, or it's conventional cutting, and it's starting at the bottom. I don't want to do that, so I'm going to reverse that toolpath. Save and calculate, and Now it's starting, oops, line cut, save and calculate. Let's see what happens here. Okay, that's better, and it looks like it's starting at the bottom. But we need to take some material off of there. Yeah, there it is. It's starting to form that radius right there. Looks like we have some material to take off the bottom here. All right, so I went way too deep. Don't need to go that deep, but I was just trying to show you that you can, if you don't have a radius cutter or a corner rounding cutter, you can use constant Z and HSS, and it will be in your system. So a lot of cool things you can do here. You can also, instead of doing one way, they have a spiral here, which is pretty fancy. Now you don't have any actual steps between them. It actually just starts here, and it does a full helix until it works all the way up to here, which is very nice. It's one constant toolpath, so you don't get, connection points. Especially if you didn't have a gap here, you could have a witness line where it moves from one toolpath slice to the next. So, all right, I think that's it. Let's go ahead and take some questions if you have any, and then I'm going to go ahead and close up shop today. Let's see, we covered those two questions. And Brad, make sure that you send me an email because I probably will forget, and I don't want to forget. So make sure you send it to darren.bryan@solidcam.com. Just say I'm requesting the video. And wait for another minute or so, see if we have any questions. I think I might go to a third class for programming, but I'm not quite sure. And if we do that, that'll be next in 2 weeks. Next week is going to be the same webinar, but inside Inventor Cam. So everything you saw here will just be presented inside Inventor. So in 2 weeks, in fact, I'm not quite sure what I have scheduled for that. I don't think I have anything scheduled. Let me double check. Nope, nothing scheduled. So next week on the 4th, it'll be SolidCAM Basics Part 2, and then I'm going to start a new series. So since I'm starting a new series, please be serious about this. Send me an email if there's something specific you guys would like to go over. Anything, doesn't matter. Send me an email, give me a suggestion. So I've got time, it's open, and I'd like some new videos to create. So all right, I don't see any extra questions coming in, so I'm going to go ahead and close this out. If you think of a question later, just send me an email. If you want the recording of this video, just send me an email. Or if you have suggestions or critique, that's fine. Send me an email. Not a problem. I appreciate you guys showing up. Hopefully we'll see you in 2 weeks, and you guys have a great day.